Here's this problem. I figured I'd walk through it. So what you've got to remember, the big formula that you've got to remember here is how does the standard deviation change when you change the sample size. So what you need to do is you need to take that standard deviation they give you, whether it's a sample standard deviation or a population standard deviation. It's the same formula. Okay, and we'll use these a lot in Chapter 7. So that's all you have to do with it. So for this one, they're telling us the standard deviation of these potatoes is 1.2. So all these following examples, I'm just going to take this, whatever they tell me for a sample size, substitute it in, and then that'll be my new standard deviation for that sample. I'm going to do the first couple, then we're going to talk a little bit theory about it all, and then we'll come back and finish these problems. So for A, we get a sample size of 4 potatoes. So 1.2 is our standard deviation for the population, and which symbolically we should be using that lowercase sigma. And then we're going to take and divide that by the square root of 4, because for part A, we're talking about 4 potatoes. So 1.2 divided by 2, because the square root of 4 is 2, is 0.6. So now you can use z-scores and undo this to table if you prefer, but I'm going to show you how to do this with the applet because I prefer using the applet. So I've got what I did here for this is I said, okay, so they're looking if the mean's 8 and the new standard deviation is 0.6, what's the probability of getting a potato that weighs less than 10? Well, so I substituted in and I put in 8, I put in my new standard deviation, and I want to know below 10, and well, practically all of them. So, because 10, if you look at it, here the applet set up the nice 68, 95, 99.7 standard deviations, 1, 2, and 3 standard deviations above and below the mean, and 10's way up above that. So we know it's going to be a pretty high probability, and as we can see, the answer's here. So what's going to happen if we do a sample size of 20? What is having a 20 here in the denominator going to do to this standard deviation? Well, if you thought about it while I paused, it's going to make it a lot smaller, and that's what we'll see. So this new standard deviation becomes 1.2 over the square root of 20, and if I still have my calculator here with that number on it, what is that? So I had to round. I went 0.268 is what I used. So I'm going to do, it's basically the same question. The only thing that changed is now I've got this smaller standard deviation to use. So I used my applet. I said, okay, mean was 8. That's smaller standard deviation. 10 is way off the chart compared to 8. So the probability of getting it is practically 1. I mean, it's very unlikely any of my potatoes are going to weigh more than 10 if 8 is the mean. And remember, the average. I'm sorry, I should be saying these are the. If there's no way I can get a sample. If 8's the true average, and I take a sample of 20 potatoes, there's really unlikely I'm going to get an average potato weight greater than 10. Because 10 is way off the chart. If I do, then 8, that average of 8 is called into question. And that's kind of where we go in the next week, in the next chapter, or in 2 weeks. To do, because after I did those 2 questions, I thought, well, that's kind of boring. I mean, 0.99 and 1. So I said, well, what happens if, I've got the average of 8, and what if I don't have a sampling distribution? What if I'm just looking, what's the probability of one potato weighing more than 9 ounces if the average is 8? And so I set up the applet for that. Notice the standard deviation is 1.2. If you wanted to think about that formula, 1.2 over the square root of 1. Well, the square root of 1 is 1. So, I mean, really, we don't have a sample if we're taking a sample of 1, is what the point is here. But, so it's not really a sampling distribution. So, but anyways, the probability of me having a single potato that weighs more than 9, if the mean is 8, and that's standard deviation, is, well, it's a fairly high probability. 20% chance of getting that, so that's not unreal. So for this one, I had a sample size of 4. You're just going to have to trust me on it. That if I took 1.2 over the square root of 4, I get that for a standard deviation. So now I've got the sample size of 4. Look how much smaller the probability of having a group of 4 potatoes have an average that's 9 or more. Same setup, just because now we're into a sampling distribution. A lot smaller probability. The last one for a single potato is 20%. This is under 5%. So its sampling distributions vary a lot less than the regular population, which is a useful tool we're going to make use of here shortly. So smaller probability. What's going to happen if we do a sample size of 20? What's going to be, how likely is it to get an average potato weight of 9 ounces if the mean is 8? Well, that's what I'm going to look at next. So I did, to get this standard deviation, I did 1.2 over the square root of 20. And look how small a chance it is of getting an average of 20 potatoes. So the average weight of 20 potatoes being 9 or more, it's almost not going to happen. So the question, what happens here, and where we're going to go with this, is if I had to interpret this result, I mean, it's very unlikely, if this is the average, that I'm going to get an average of 20 average weight of 20 potatoes that's 9 or more. So if I do, that calls into question either my sample was bad, it was a bad sample, or that average of 8 is not correct. So now I'm going to go on and keep going with these questions. So part C says, what's the probability of getting a group of 6 potatoes? So in other words, my sample size is 6, that the average weight of those potatoes is between 7.5 and 8.5. So what we have to think about, okay, so I've got a sample of 6 now. Okay, when you do that on your calculator, you got to do some liberal rounding. You get 0.49. So that's going to be this. That's going to be the standard deviation when I have a sample of 6. So, but before I went there, I said, okay, so how likely is it to get a single potato? So I said this is just the probability of getting a single potato that weighs between 7.5 and 8.5. Notice it's at 1.2 for the standard deviation. So there's a 32% chance of getting a potato that weighs between that amount. Okay, now to answer the question, here's the sample size of 6. A much greater probability. See, there's a lot less variation. If you look at let's see, can I move that out of the way? Yes, I can. If you look at the standard deviation marks for this, so here's the regular population, no sampling distribution. I'm going from 8 to 9.2. It's adding 1.2 every time, and here I'm adding 0.49. You see that 9.4? Well, for the sampling distribution, almost all, or 99.7% of all samples of size 6 will fall between those two numbers. That is just over 1 standard deviation in the population. So you see how much smaller that spread is? And that was just with a sample size of 6. Okay? And that's why that probability was so much smaller. Now what if we go with a larger sample size? A sample size of 20. Okay? Almost all those samples of size 20 will have an average between 7.5 and 8.5, and you can see that. So the sampling distributions, and also look at the spread here. I mean, you're within well, sample size at 20. Gosh, what do we add here with a sample size of 4? We're within 2 standard deviations of the sample size of 4, and we're all within 1 standard deviation, aren't we? Yeah, 8.8. Yeah, so we're within 1 standard deviation of the regular population. So see, sampling distributions have a lot less variation, which means those averages. So this all just deals with how samples behave. We aren't talking about how good a sample you have. We just want to know how the random samples behave. So for this very last question in this problem, it says, so we get an average of, so we buy a bag of 6 potatoes. And we're selling bags of 6 potatoes, and the whole bag weighs 42 ounces. So how do I know whether I'm being cheated or not? Well, if I've got 42 ounces I can say on average each of those potatoes weighs 7 ounces. So I've got a sampling distribution, average of 7. So is 7 unlikely to happen? So I'm going to come back and look at this distribution. I had a sample size of 6, so that's my standard deviation there. And my mean, I said below 7. Well, there's a just over a 2% chance of me having a sample of 6 potatoes with that low an average. Well, 2% is less than 5%, so that means it's an unusual event. So yeah, I should probably feel cheated because it's not likely. It's not likely if this is the true average that I'm going to get an average potato weight that small. Okay, so that's how you use that unusual event idea. So hope this helps. We can do some more problems if you want.